Today we will explore or we will start the DAX topic. So as part of the DAX, we'll give you an overview of what is DAX is all about and why we need to use DAX and when to use DAX functions. And also we will take a deep dive to understand the mechanics behind the DAX functions, the architecture, okay, the Vertipaq engine or X velocity engine, and then we will move ahead and explore the operators, different types of operator and data types that are available in DAX. Followed by this, we will take a look at the aggregation functions, rounding functions, logical functions. What is a DAX? DAX stands for data analysis expression. Okay, it is a collection. DAX is a collection of functions, operators, and constants that can be used in a formula or expression to calculate or return one or more values. So with DAX, you don't have to write so many lines of code. Okay, the built-in functions, with the help of the built-in functions, we can perform complex calculations such as year-on-year sales, running totals, like-for-like sales, and so on. DAX assists drawing insights from the data. Even the complex data we can draw or some insights. Okay, DAX is not only used in Power BI. Please remember this. Oh, I'm sorry. I don't know what happened. Got disconnected. And we will resume the session now. So it helps us to assist drawing insights from the data. It is not only used in Power BI DAX. Okay, DAX is used in Excel Power Pivot and SQL Server Analysis Services Tabular Edition, and also Azure Analysis Service also DAX is used. Okay, so Power BI supports two languages. We know very well about the M language. We already discussed about the M language. The M language is generated behind the scene in Power Query Editor. Okay, apart from this, we have DAX. You cannot use DAX in Power Query Editor. Okay, M and DAX are independent upon each other. So M is different, DAX is different, right? So you cannot use these two things simultaneously. Okay, in Power Query Editor, you cannot use DAX. Okay, so DAX is an analytical data calculation language. Okay, and this is a M language, the Power Query Editor language. It is generated automatically, but we can customize it. But we don't have to write explicitly the M language, M script. Whereas here, I'm sorry, oh, screen is not shared, right? Okay. Aruna, it is recording, Aruna. See, it is recording here. Okay. Okay, so that's what. Okay. So next, we will understand the DAX engines. So DAX engines are the powerhouse behind the Power BI. Okay, DAX. Okay. So the DAX formula is processed by two engines, the DAX queries. DAX functions or DAX queries, it is processed by two engines. One is formula engine, other one is storage engine. So these two engines work together to compress and encode the raw data and access DAX queries. So these two engines work together to compress the data and encode the raw data and access DAX queries. So what is compress? It's something like a zip. Okay, so if you compress the data and if you load the data into memory, the compressed data, you don't require too much of memory. Okay, and also what this engine does is it compresses the raw data also. Sorry, it encodes the raw data so that it uses the storage space optimally. Next, we will explore the role of formula engine and storage engine. The formula engine is responsible for accepting the DAX query. See, in this Power BI desktop, in the report canvas, I just go to report canvas. In the report canvas, you want to create some, here I have created a DAX function. Let me check. Yeah, total sales measure, that is the one I already created it. Let me see if it is there already. Yes, it is the, look here, this is the measure. In this measure, I have used a DAX function, simple DAX function, sum function. Okay, this DAX function, the moment when I drag and drop this measure, so this is called your total sales measure. We'll discuss in detail about what is measure, what is calculate on little later. At this moment, you just think sum function is a DAX function or DAX query. Well, simply the moment when I drag and drop it from here to here, we can see the value of the measure. Okay, the moment you create a DAX, you cannot see the, or as soon as you create the measure, you cannot see the data or the values. If you want to see the values or computed by the measure here, you need to drag and drop it to any visual. In this case, I have used the chord visual. 1, 2, 3 is a chord. That visual, I drag and drop this value. So when I drag and drop, what happens is the formula engine is responsible for accepting this query, the DAX query, and it processes the query. Okay, and it processes the query, and then it generates something called query plan. First thing is the formula engine, it accepts the DAX query. So what is the DAX query in our case? Sum of some function, right? And it processes the query and generates a query plan. If you are, let's say if you have used the import connectivity mode to load the data, what happens is the formula engine, it sends a data request to the storage engine, because the formula engine cannot directly retrieve the data from your data set. Okay, so he has to depend on the storage engine. So once the request has been accepted and processed and the query plan has been generated by the formula engine, this query plan will be sent to Vertipaq, and this guy, what he does is, in the case of import mode, okay, so what he does is he compresses the data. So this Vertipaq engine, what it does, it converts the tabular data into columnar database, and then it encodes the data and compresses the data and load it in memory. I discussed about this. In import connectivity mode, the data will get loaded in memory in your laptop and your local server. So it is an in-memory columnar database. What is columnar database? We'll discuss it little later. Okay. And in case you are using direct connectivity mode, the formula engine, what it does is, okay, before we get into the direct query mode, see in the case of import connectivity mode, the Vertipaq, what it does is the one responsible for generating the cached data, and then he sends the cached data to your formula engine. Okay, in the case of direct query mode, what happens is, the Vertipaq is not at all coming into picture. So now instead of Vertipaq, they call it as a X velocity. They renamed the Vertipaq engine as a X velocity. Okay, so in the case of direct connectivity mode, the query plan will be sent to your directly to your SQL server. Instead of sending the query plan to your Vertipaq, the query plan will be sent to your SQL server. Got it? And then the query plan will be sent directly to your SQL server. The output of the query will get sent to your formula engine. So now you understood in both connectivity mode, right? So in the import connectivity mode, the X velocity engine, which is nothing but the Vertipaq. Previously they used to call it as a Vertipaq engine. So it is a piece of software. Okay, what it does is, it takes your Excel data or tabular data and convert your tabular data into columnar data. Because the columnar data, if you store the data in columnar, the performance will be much faster. On top, if you compress the columnar data and then encode the data and then load it in memory, it will be much faster. So Vertipaq or the X velocity is taking care of that. But in the case of direct connectivity mode, the query plan is generated by formula engine, like in the case of import mode. What it does is, it sends the query plan directly to your SQL server. The SQL server will execute the query and send the data back to your formula engine. Okay, so what happens is, right, I was telling about this one. In the case of Vertipaq, it converts your tabular data into columnar data, and then it assigns or it encodes your column values, and then it compresses the data and load it in memory. In the case of Vertipaq engine only, in the case of import module only, this is what is happening. Storage engine, what it does is, upon receiving the query plan in the storage engine, right, for the import mode, X velocity or the Vertipaq, what it does is it converts your data into columnar data, and then it compresses, encode data in, and load the data in memory, so that the performance will be much faster. So now you understood the architecture behind the DAX engine, how it works. That's what I mentioned it here. If you work with the directory, you cannot use the Vertipaq storage engine. Since you cannot use Vertipaq storage engine, you cannot convert the tabular data into columnar database, and you cannot do compressing all the things. Okay, so all these features are available only with Vertipaq or the X velocity. So what is X velocity in Vertipaq? The new name for Vertipaq engine is nothing but X velocity. X velocity is a piece of software. That software, what it does is, it does all these things. Convert your tabular data into columnar data and so on, and then it compresses the data. So now let us try to understand what is the advantage of columnar database. Why Vertipaq or X velocity convert the tabular data into columnar data? So what are the examples for columnar databases? The example for columnar databases are, you have something called Cassandra. One second. Cassandra, and you have something like HBase, and you have something else called Vertipaq. These are the examples for columnar databases. It is always good if you know more than one technology, so that you can give more solutions. Your companies will consider you as a most sought after guys. They will consider you as an asset. They are okay to pay anything. Okay, so example for columnar data, Cassandra and HBase in Vertipaq. Even in the case of Power BI, in the import connectivity mode, the Vertipaq engine or the X velocity, what it does is converts your tabular into columnar data. With columnar databases, the single column access is pretty fast and effective. Okay, so let's say in your table you have 100 columns are there, but you don't need all the 100 columns. All you need is, let's say you need only 3 columns data, for example name, column and unit price, or only 2 columns. If you convert your tabular data and store it in columns like this, what will happen is, so when you query the name column and unit price, it will directly go here. So now you might be asking this question, okay, even what is the difference between tabular and columnar? Even in the case of tabular, it goes and, so in my tabular, for example, if I use a select query, it will go and select only, in my select query, if I use only these 2 columns, obviously it go and pick up the data from these 2 columns only, right? So that is what you will ask. It is not that way. Even in the case of RDBMS, if you use select statement, even your select statement, if you use only the selected columns, what happens is, behind the scene, it first goes and check whether this column is a name. No. And it goes and checks the second column. Likewise, if you have 100 columns, it goes and checks each and every column. Is this a name column? Is this column name is unit price? It keeps skipping until it finds the columns that you wanted. Skipping takes more time. In the case of tabular, it keeps checks until it finds the columns that you are interested. Whereas in the case of columnar database, it need not to go and skip, because you store each and every column values itself separately. What happens is, it goes directly to the respective column, so that even if you have 100 columns, it directly goes to the respective column and fetches the data. And Okay, so in the case of right, so the tabular databases increases IO, right, because of many scans of useless data, whereas the columnar databases are more CPU exhaustive. Okay, but yeah, it requires a lot of CPU. Okay, but when it comes to performance, the columnar database are outperforming your tabular data. So that is the reason why what Microsoft they did, they have created a software piece called X Velocity. In the past, it was called as a Vertipaq. Okay, okay, X Velocity. The recent name is X Velocity. Okay, so what they developed a piece of software like X Velocity. What it does is it converts your tabular data into columnar data, so that the performance will be much faster. You need not to skip the unnecessarily, on the irrelevant columns. Okay, it compresses. Sorry, first what it does is converts your tabular data into columnar, and then it does the compression. The next step is Vertipaq does the compression in the case of import mode. So, what are the advantages of compressing the data? It is simple common sense. If you compress the data, it will reduce the amount of memory required to process your query. It not only Vertipaq compress the data, but also it encodes your data. Okay, so for to do the compression, it uses some algorithm, some technique. That is what you are encoding. Okay, the Vertipaq stores a compressed copy. Once it compresses the data, it copy the data into database memory. Okay, and then the compressed columns make your code and query run faster compared to an uncompressed column. So they are generally called encoding. So what technique the X Velocity engine is used to compress the data? There are three different techniques. One is value encoding, the other one is dictionary encoding, the third one is run length encoding. The value encoding, this type of encoding is done only for the integer values. If your column has integer value, right, so then value encoding technique or the algorithm is used to compress the data. Okay, in the case of text values, hash encoding technique is used, and in there are some cases the RLE, run length encoding mechanism or compression technique is used. Okay, so we will take a look at each and every compression technique. So value encoding, we'll start with value encoding compression technique. What it does is it works with integer values. Now let us look at this data. In this data, can someone tell me what is the minimum value here? What is the minimum value here? 194. What this does is value encoding technique. It finds out the minimum value and subtract the minimum value from for each and every value. So 212 minus 194, 18. 197 minus 194, 3. It subtract the value. It subtracts the minimum value from each and every value, and then it obtains this value. Okay, so this is what your value encoding. And if you look at these values, the maximum is 22. The maximum is just 22. So in this case, right, the Vertipaq discovered the values by subtracting the minimum value from all values of the column. It could modify the range of the column. Okay, it reducing it a range from 0 to 22. So in this case, it reduced the range from 0 to 22. Instead of 194 to 216, it reduced the range between 0 to 22. Hence, it requires a less bits than storing numbers up to 216. So in this case, what we are doing is, here it requires to store 216, 8 bits needed, whereas to store this one, it requires only 5 bits in the memory. In this case, we are saving 3 bits. You might be asking this question, or while these 3 bits might seem a very small saving, but when you multiply this for a few billion records, you can make out the difference, right? So for this 8 records, you are saying 3 bits. What if you have 25 million records? 25 million into 3 bits, then you are saving a lot of space also by doing encoding. So after you do the encoding and if you compress the data, again the memory to store this value is very less, right? It doesn't require too much of memory. That is what I'm trying to say. This is called your value encoding. See, using value encoding, we are reducing the number of bits needed. That is the whole objective of value encoding, so that it will not take too much of storage to store the values. Next technique is hash encoding. So this type is used on text values. For example, I have a column by the name of color. What happens is it creates something like a dictionary kind of thing here. And first it finds out all the unique colors. Red, right? So it puts distinct values. Okay, it puts red only one time, and then white it picks up, and then black and blue, and we don't see any other color. Even though each color appears more than one time, here it takes the distinct colors and then it assigns for each distinct. For red it assigns 0, white 1, 2, 3. So what happens, and once you get these values for these distinct colors, it replaces red by 0. Wherever red is there, it replaces red by 0. Wherever white is there, it replaces it by 1. Wherever, look here, instead of saying blue, storing it as a blue, if you store it, if you replace blue by 3, you are saving lot of space. You are saving lot of space. This is called dictionary encoding. It is also called as a hash encoding. This works only for the text data. Next one is the run length encoding. It is actually pretty straightforward, but it becomes really powerful when it is combined with another type of encoding. Okay, now let us take a look at this. See here what happens. You have a column called quoter. You have Q1, Q2, something is there. In the case of RLE, what it does is, how many number of times Q1 is occurring, how many number of times this text value is occurring, and what it does is it maintains something. Q1 starts with one first record, and it in total we have 310 records, and Q2 we have 311, starting from 300, 200 in total. Okay, so it is 290 records are there, 310 records are there. It starts with one. This Q2 starts from 311th place. So this is 311. Okay, up to this 310. Starting from 311, we can see 290 records were related to Q2. So and what it does is, here also it builds a dictionary. Okay, Q1, Q2, Q3, 0, 1, 2, 3. It takes the unique values and then it replaces all the Q1, Q2, Q3 by 0, 1, 2, 3. Okay, and then what it does is, in 0 is nothing but Q1. So how many number of records are there for 0? How many number of records for 1 is there? The 1 is Q2. Likewise, right? So Vertipaq store, it creates a data dictionary, and also along with it, it uses another encoding technique called data rows. Using these three techniques or algorithms, it encodes your data so that the storage required to store the data in memory is very less. On top, if you compress the data, it will be less. And before compressing the data, before you do encoding, what you do is you convert your tabular data into columnar data. So with columnar data, is scanning the columns, it doesn't require much time. It is pretty faster compared to tabular. And next one is you do encoding, so that you are reducing the storage space. On top, if you compress it, it consumes very less space in your memory. So that is the reason why, compared to all the three connectivity mode, like import, direct connectivity mode, live, import is outperforming. The performance is much faster. But if you are going to use humongous amount of data, then you need to take a call on a case-to-case basis. So direct query will work. Okay, but compared to direct query and live mode is faster. Compared to live and import is faster. But import, you cannot afford to import huge amount of data. So again, you need to take a call. But these are the features that are available. Okay, this is what in the case of import connectivity mode, the Vertipaq plays a crucial role. Right, so that is the reason why the performance is faster in the case of, and also it is in memory. It loads the data in memory, right? Okay. So far we discussed about the two engines, formula engine and storage engine. The formula engine simply accepts the request and processes the query, and then it generates the query plan. It generates the query plan, and then it sends the query plan to storage engine. Hey, it is the query plan is something like Google Map, and then with that plan, he goes and picks up the data from your storage. Storage is nothing but the shop, and then once he picks up the data, he comes back and deliver it to formula engine. You just think that way. Simple analogy. Okay. The formula engine interprets and evaluates DAX, and the storage engine, it does the compression and encoding. So you need to understand the storage engine is the one that is where the Vertipaq engine is there, right? In the diagram we have seen. So you need to remember these points. Okay, so you might be asking this question. So why should I know about the DAX engine? Okay, writing efficient DAX, which means code that runs at its best possible speed, requires you to understand the internals of the engine. Okay, so that you can make sure that you are writing an optimal query. Okay, so you need to decide in that case which type of connectivity mode I should use it, right? All the things.